Integers on a temperature scale. In this video, I will discuss the behavior of integers along the temperature scale. The temperature scale is like a number line, and a common sense perception tells us that the lower the temperature, the cooler it is. A thermometer has a reading scale which is similar to that of number line. That is, it has the positive and the negative temperatures separated by 0. So on the thermometer you have 0 degree Celsius, okay, and below it we have negative temperatures, and above it we have positive temperatures. Now what happens as you move upward and what happens as you move downward? When you take reading above 0 degrees Celsius, what happens? And when you take reading below 0 degrees Celsius, what happens? I will explain shortly. The thermometer has the same reading scale as the number line. That is, we have both the positive and negative integers, including 0. Okay, now see here, what you're going to have here is this. I will use the number line to explain what happens as you move above 0 degrees Celsius and below 0 degrees Celsius. Now, from here, this is where you have the 0 degree Celsius. Then, if you go up like this, that is, you move from 1 to 2 to 3 to 4, upward like that, that means you are moving towards the positive integers. So it becomes warmer as you move up. That means as you go up, it becomes warmer. 2 degrees Celsius will be warmer than 1 degree. 3 degrees Celsius will be warmer than 2 degrees Celsius, and so on and so forth. So from the scale you have before you, that means the warmest will be 8 degrees Celsius, and the least will be what? 1 degree Celsius. So if you continue, it goes on like that. When you get to 100 degrees Celsius, that is where water begins to boil. That is the boiling point of water. So as you go up, it gets warmer. When you go below 0 degree, what happens? It becomes colder. It becomes colder. The coldest here will be -9, because the more you go down, the colder it becomes. So -1 is cold, or -2 is colder, -3 is colder, -4 is colder, -5 is colder, so and so on and so forth. But wait, this 0 degree Celsius is called what? It's called the freezing point. So next is to talk about temperature rise and temperature fall. So when a temperature rises and when a temperature falls, what do we mean by that? At 0 degrees Celsius, that is the freezing point. So when the temperature rises, that means it goes up, and that is simply addition. When the temperature falls, that means it goes down, and it is simply subtraction. Let's take for instance a temperature. The temperature of a substance is at 2 degrees Celsius. If it goes up by 3 degrees, that means you have to count up 1, 2, and 3. So that means the new temperature will be what? Will be 5 degrees Celsius. So also, if the temperature of a substance is -1 degree Celsius and it falls by 4, that means you have to go down 4 times. Then you have 1, 2, 3, 4. So that means the new temperature will be -5 degrees Celsius. So in another way, when the temperature rises, it means addition. That means when the temperature was here, that is 2 degrees Celsius and it rises by 3 degrees. That means you can easily add 3 degrees Celsius to it and you still get 5 degrees Celsius, just like what we got here. So you can do the same thing. So for the negative one too, when the temperature of a substance was at -1 degree Celsius, it fell by 4 degrees. That means you have negative, that is minus, because it fell, okay, by 5 degrees, by 4 degrees, because it fell by 4 degrees. So you subtract 4 degrees Celsius there, and this will give you -5 degrees Celsius, just like what you have here. So you can make use of your number line to still get the temperature fall or temperature rise, and you can also use addition and subtraction to get it on time. Are we done? Not yet. Let's look into a temperature at 6 degrees Celsius here, and it falls 10 times. So what will be the new temperature? So you can see that we are currently at 6 degrees Celsius, then here we are here, so we need to go down 10 times because it falls 10 times. So let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. The new temperature will be at -4 degrees Celsius. That will be the new temperature when the temperature of a substance at 6 degrees Celsius falls by 10. So instead of you counting all the way from 6 degrees Celsius down to -4 degrees Celsius, what you can simply do is just to say that you are at 6 degrees Celsius here, then it falls by 10 degrees. So you just subtract 10 degrees Celsius here, and this will give you -4 degrees Celsius. So you can see that you simply have your answer as well. So it is faster when you make use of addition and subtraction compared to you counting up and down, but the two are good. Just understand it very well. When you have a small number, you can use the counting method, and if you have a big number, you can easily make use of what? The addition and subtraction respectively. Now it's your turn. I want you to do this. Sasha, write the height of a point that is 50 meters below sea level as -50 meters. How does she write a height that is 200 meters lower than that? How does she write a height that is 200 meters higher than that? So when you have the sea level is just like you are at 0. That is the sea level. You are at 0. So above will be the rise, and below will be the fall. Okay, so just like the concept I just explained on the previous page, so you can use the same thing to do that. So what will be the height when it is 200 meters lower than that 50 meters? Okay, so that -50 meters rather. So what will be the height that is 200 meters lower than that temperature? This dot is pointing at this. Okay, it's pointing at -50 meters. I want you to attempt this. Under this video, you can go to the comment section and put your answer there.